Hello, everyone. Welcome to our webinar. My name is Audrey Bian. I'm a Principal Product Marketing Manager at Broadcom. So I focus on Kubernetes, on VMware Cloud Foundation. And the topic for this webinar is the new cloud playbook, Kubernetes, private cloud, and open source. So I have Lee, Sustar, and Natalie Fisher joining me today. Lee and Natalie, would you like to give yourself a quick intro to the audience?
Hi, Audrey. Thanks for having me. Lee Sustar, Principal Analyst at Forrester. I cover cloud native technologies.
And I'm Natalie Fisher. I am a Principal Product Manager in VCF, and my focus is on our vSphere Kubernetes services. And my role basically covers end-to-end lifecycle of how Kubernetes runs natively on vSphere, from the underlying architecture and the integrations, all the way to the modern services and ecosystem.
Awesome. Excited to co-present with you guys. And Lee, now I hand over to you.
Audrey, I'll go ahead and share my screen here to get going. So today I'm going to be talking about the application modernization, acceleration, innovation. And that's something that, I want to make clear that when we talk about cloud technologies at Forrester, we mean that broadly. It's not just in the public cloud. It's the way to describe technology as it's evolved. I'll go through that in my presentation. I'll go ahead and move it. I did introduce myself. I cover cloud strategy, architecture, modernization, cloud operations. Increasingly, I come out of the security, governance, and risk background as well, and keep up those practitioners, because I think security is always paramount to whatever we're trying to do here. Cloud native technology is really something that is not limited to the public cloud. It is a new way of working. It's based on cloud native technologies such as Kubernetes, which we'll talk a lot about going forward, that has really become prevalent. And if you look at some of the market research from Forrester, our surveys, you can find some very interesting trends here. Cloud native is getting momentum well beyond public cloud. Obviously, security is a big part of that, observability. But I want to call your attention to the development platforms, Kubernetes at the edge, service mesh, WebAssembly, or WASM. These are technologies that the enterprise is embracing, whether they are focused primarily on public cloud or primarily on private cloud. Oftentimes it's both hybrid scenarios. And the numbers show that out. What people are after is the technology for modernization, which is cloud native technology on the Kubernetes open source ecosystem, and they're implementing that in whatever ways make sense for them as an organization. It might be at the edge in certain cases. It might be around development platforms, sometimes more build your own, sometimes more like a platform as a service. And clearly, the surrounding technologies to make this viable for the enterprise are proceeding at pace, with security being paramount, and also observability. As you get into the cloud native ecosystem, there are new challenges around microservices, service mesh, and so forth, where observability, AI ops, and so on become really paramount. And if you want to look at where people are spending their money, yes, public cloud has got momentum. Yes, public cloud companies are big multi-trillion-dollar entities. That's not going to change. But if you look at the enterprise, and what our users are telling us is that they are going to also spend money on private cloud. 78% of cloud leaders say they want to increase spending on private cloud. I think there's a number of reasons for that. Cost management is one. The need for private and sovereign AI is one. The need to maximize and build upon the investments that have been there for data centers that have been working at scale very well, and continue that practice. So that's very important. And in terms of the application modernization, that really dovetails with that effort. So the application modernization effort isn't really just synonymous with moving to the cloud. It may be, those things may come together, but increasingly we see them taking place really as a self-reinforcing, self-motivating effort, as long as that underlying enabling technology in the cloud native ecosystem, principally Kubernetes, is there. So if you look at these numbers in terms of containerization, which I think of as a proxy for Kubernetes adoption, that's really the dominant way in which containerized applications are being orchestrated today. If you look at the numbers here, you have overwhelming majority of of organizations are using containerization, not just for new projects, right? That would be expected. That they're on the right, the new and existing products or new projects, but increasingly current applications, doing it this year, next year, in 1 or 2 years, 1 out of 4, 1 out of 5. Those numbers are quite compelling. So what we're seeing here is an overarching modernization effort focused on applications, because that's where customers get engaged, partnerships take place, where money moves, how money moves. Application modernization is critical to that. So we're not seeing an infrastructure modernization on one side and application modernization lagging behind. They're going together, and they work together in symbiotic ways, and they work together whether it's in a public cloud scenario or a private cloud scenario, or increasingly, I would say, the edge. And if you look again at the numbers, 1 in 5 say they're using containers to build internal private cloud. And that's considerable, because again, if there was an identification with containerization always moving to the cloud, that's actually not necessarily the correlation. We see numbers that are taking place quite a bit different from that. And if you look ahead at what's driving that, you see a series of numbers that are driving modernization. Let's go through them. It's a bit of a long and dense slide, but it's worth going through a little bit in some detail. If you're going to design for modernization, you have to understand your domain and business requirements. That is kind of an old saw. People talk about that a lot. It's not terribly new. But when you think about the cloud native capabilities around orchestration, the way in which the business needs to be more agile, they need to have greater stakeholder engagement from the very beginning in terms of capturing user stories, developing application is right there. So you have to understand the domain and business requirements at the application development level. And that means you're establishing the context and boundaries for that applications. What's it going to do for whom and when and how, and the boundaries of that. Does that need to be delimited in some fashion for whatever reasons, be it security, be it for just a cleaner implementation and integration points. You have to, decomposing legacy applications. That can be some effort, but there are tools and capabilities around that today. Then you move ahead to prioritizing domains you're focused in, establish protection mechanisms. That's inclusive of security, but also governance and risk and compliance. And also just bad business outcomes aren't necessarily a formal security issue, but would have an impact, reputational or otherwise, on how business would operate. Event-driven design, obviously that's been prevalent for some time. Containerized applications can move in that way, so people are looking at that for their modernization. Refactor when possible, as opposed to completely rebuilding. Mapping relationships, which can change as the big monolithic applications are decomposed, and you can start to move functionality in different directions. The services around them per domain, what kind of documentation changes you might need to have, and of course the testing. So these are all the kinds of things that go into domain driven design for modernization. So open source flexibility and security and platform power are really driving Kubernetes adoption. So if you think about those modernization requirements, there are several of them. They're all important. Kubernetes can get you in that direction because it uniquely was built to orchestrate containerized applications at scale, so that the containers and the underlying infrastructure can be integrated and presented to developers in such a way that they can be much more productive, either writing net new, but also in modernizing applications. And that open source flexibility is key. And I want to talk about a little bit more about how Kubernetes works on that. So if you think about how Kubernetes was developed, it was a big open source project, consortium. It has some origins in some Google technologies and was quickly embraced by VMware, now Broadcom, Red Hat, Microsoft, and others, eventually AWS. And really it was a convergence by a lot of big technology vendors for both private and public cloud, who understood that the virtual machines have their place, but actually in terms of scalability and horizontal scaling and also vertical scaling, Kubernetes offered a series of advantages that would need to also be brought into the picture for enterprise IT. And essentially the genius of Kubernetes and I don't think that's too strong a word really, is to find the core infrastructure components, find out how they could be consistently deployed across very different environments, public cloud, private cloud, the edge, and then build from there. So you had a kind of an abstraction from different kinds of infrastructure on the one hand. So if you see in the left hand of this diagram, edge, public cloud, private cloud, and a multi-cloud hybrid cloud. And that workload decentralization then allows you to start to have some platform-driven innovation. And that could be, so essentially, if you have a common denominator of the Kubernetes infrastructure based on Kubernetes pods at scale with a control plane, you can then build out particular platforms on that common strata that could address particular use cases. It might be blockchain, metaverse, could be big data. Obviously, AI and ML is a big part of that. And once you have those sets of platforms, the platforms could then be extended up further up the stack by platform teams, tweaked towards whatever the organization needed. It might be low code for something facing the business. It might be stateful applications or stateless applications. Kubernetes was probably initially focused on stateless application, not a lot of backend data, not a lot of no real state there. Quickly moved in towards stateful applications, and the community built that out to support that. Could run on bare metal, could run on VMware and other virtualization technologies. So you have an application modernization that's really facilitated by the common horizontal structure around Kubernetes, the platforms that can be built upon those for particular domains, and then the platform team operations all the way up to app modernization in ways that are quite efficient and really open the way to modernization for organizations of all types. All based on open source. And if you look at this diagram, it's another way of kind of stepping back and finding out what's going on. So if you look at the Kubernetes cloud-based ecosystem, you can look down, say, at the bottom right of where the infrastructure and development open source projects that are contained within these categories are quite developed, right? They're quite mature. They scale. They develop, and the operational things surrounding them, things like open telephony and all kinds of different security innovations that have come out, like OPA, policy agents, and so forth. These have enabled Kubernetes to be a very rock solid core infrastructure. And that's because on the left, you have the kind of communities from the CNCF and open source community more broadly with the CNCF and the Learning Foundation driving that forward. And then that gives you particular innovation domains around the various types of platforms. And of course, the modernization efforts on the upper left-hand corner that we've been discussing. So it is Kubernetes just recently passed its 10th birthday, a few months back. It is now considered to be one of the core constituent elements of the modern enterprise IT. And some of the key drivers of Kubernetes and containers in the private cloud, I mean, the public cloud is well understood because a lot of the public cloud providers helped develop that overall. But some of the key drivers in private cloud are the same as they would be in public cloud or the edge. Security and compliance, critical issue, because while Kubernetes was designed to be open without a lot of pre-built security, understanding the security community would rally around that, build that out, that's been achieved. Infrastructure optimization, tuned for bare metal, tuned for running on VMs, scalability performance, both horizontal and vertical scaling, modernization efforts, developer productivity, and application portability. So you could build an application on public or private cloud and have the capacity to move that as your needs change over time. And the developer productivity resulting from that, meaning that developers don't have to do rework from one environment to the other, at least not a lot. They have to adapt the container, of course, to the new infrastructure, but a lot of core applications can remain as they have been. And we have seen this in numbers, right? So Forrester runs the total economic impact model for Kubernetes and containers, and that's based on the TEI studies we've done for a number of different vendors, looking at their customers, interviewing them, running the numbers. And the key takeaways when we combine all those studies is that if you look at Kubernetes and containers as part of modernization, you can have a 40% reduction in operational labor, 90% reduction effort for releases for developers. That's quite the transformation, and a 10% reduction in developer time spend on non-coding activities. So developers are developing; they're not wrestling with the integrations in the same way because they can be presented consistently over time with that underlying Kubernetes platform. That's a major change. And there's other reasons for private cloud getting good momentum. They're outside of technology. There's rising regulatory pressures, like the EU's AI Act. You've got geopolitical fragmentation today, whether that's export bans or domestic security laws. And you've got cost performance achievements. There are things happening in private cloud with highly capable AI focused hardware that are delivering at scale, good total cost of ownership, which make private cloud viable for some of the key AI apps today. And there could be a simplification of that if you're using a well-established open source Kubernetes platform. And if you're going to the upcoming KubeCon conference in Atlanta in a few weeks, you'll see that on display. And this is where we're heading. This is what happens when Kubernetes is really kind of generalized further across the ecosystem. The ecosystem now which was previously the focus of the earlier slide, see there on the left, multi-infrastructure, multi-cloud, industry cloud, and series of composable efforts around any number of different undertakings, whether it's quantum computing down the road or something more immediate around generative AI today. For particular medical implementations, say brain-computer interfaces, it's all there. And further up the stack, you see the operator and developer cloud experiences are going to be increasingly, they are right now. Obviously, we know about various technologies, what Forrester calls Turing bots, AI-assisted code development. That's proceeding at pace. That's only going to continue. And platform operations is increasingly to become more intelligent based on some of the efforts that's going into the Kubernetes and cloud native ecosystem. So we think this is a very important hinge point really in technology as people have talked about in terms of AI. But I think we have to remember that what's powering all this is the open source Kubernetes based ecosystem. That's what made generative AI and now agentic AI possible at scale. And the more day-to-day, more immediate tasks in front of us in terms of modernizing existing apps, bringing them into new cloud functions. This is where Kubernetes is also shining. It's not just driving ahead with the new technologies, it's on the modernization that has to take place across the enterprise today. So that's what I have. So thank you, Broadcom, for inviting me here today. I'm looking forward to hearing what my colleagues have to say next.
Thank you so much, Lee. That's the next topic. Let's talk about the VCF, VMware Cloud Foundation. And on my portion, on my section, I will talk about how our VCF would benefit to three key personas. Now, let's get started. So this is a diagram which kind of illustrate how VMware Cloud Foundation will go with VCF in the whole presentation, which is gonna deliver a built-in Kubernetes runtime through vSphere Kubernetes service. So we use the VKS as the acronym. So starting from the bottom, we can see VCF will provide a compute, storage, and networking layers, which ensures performance, security, and efficiency at the infrastructure level. And with VKS, it provides an enterprise-ready Kubernetes environment. It includes a set of CNCF open source services in the box we can see, and such as Paynet and Vera. These are all packaged in our CNCF open source services in VKS. So on top of this foundation, there's a wide of services such as private AI services. Now it become part of the VCF. We have VM service, network service, storage and data services, which make VCF a complete and a comprehensive platform for both VMs and containers. So at the center is our multi-cluster management. It's also being added in VCF from the Tanzu. which simplifies operations across environments with the lifecycle management, like policy enforcement, governance, which are so critical for organizations when they want to scale Kubernetes across the teams or different locations. And this environment supports the need for multiple personas, basically 3 personas. They are so important in VCF, and we're gonna talk more details about these personas. And let's start with like a cloud admins. So with our VCF cloud admins, they can manage underlying infrastructure resources with policy and governance. And for platform engineers, now they can configure and maintain Kubernetes clusters and services. For developers, they can consume APIs and self-service tools to build modern applications, which include, like we mentioned, AI, ML workloads, distributed database, and more. So the other thing is really important I want to mention here is, so this architecture is also extensible and open. We enable our customers, they can integrate with the CNCF compliant third-party services, which giving them the choice and the flexibility. So now let's dive into the personas, how VCF benefit, bring the most benefit to them. First, let's start with our cloud admins. Oh, sorry, just give me 1 second. I think we should, am I missing one? Okay, so anyway, let's start with our cloud admins. So first is the single platform for VMs and containers. VCF provide a single platform to run traditional and modern workloads. It is simple for them to operate with fewer silos and consistent tools across all the environments, which also facilitate with their career growth, something maybe could put into consideration as well. So as a VI admin before in the VMware environment, now they can get the knowledge and develop their career into the cloud admin who are ready to manage modern workloads. And then second is simplify the Kubernetes operations with existing skills. So instead of retaining, so they can extending this instead of retraining, so they can extend this existing skills and the Kubernetes lifecycle management also from like positioning, upgrade, scaling, all built into the familiar workloads for our cloud admins. The third one is policies and governance and control. So cloud admins, they retain the control they need to enforce the compliance and operational consistency, which is really important. And they also have a centralized policy and a governance ensure the team, they can move fast without like compromising standards. The fourth one is the N-2 Kubernetes versions. Let me explain a little bit what the N-2 means. So it means we support most recent Kubernetes versions, which are compliant with the CNCF community. And also not just the latest one, we also support the previous 2 versions. So which would give the flexibility for our cloud admins to avoid, disruptions when developer, they need a time to validate or migrate workloads. So they can stay on the previous versions and, upgrade with their own pace. And the last one is security. So we provide 6 layers of the fraud and cyber threat isolation. Why this is important? Because when organizations, they increasingly adopt Kubernetes from modern app workloads, security and false installation becomes so important. Like traditional Kubernetes platforms, they only provide like basic isolation at the namespace and cluster level. So which could leave the enterprise exposed to security risks like a noise neighbor issue, and operational failure. So with the VCF, we enforce the security and the workload separation with the 6-layer of multi-tenancy mode, ensure we have a better fault and a cyber threat isolation. Now let's take a look on for the platform engineer. So they are also very important for us. So we want to make sure, we want to make sure that we make their job easier. The first is we provide a CNCF certified Kubernetes runtime. So this ensures VCF we are consistent with the CNCF Kubernetes certified Kubernetes community, like customers, they avoid like a vendor login and then maintain the capability to stay, like I said, in the -2 version as well. And by the way, we have our VKS 3.5 announcement will coming soon. The second one is a long-term support for all Kubernetes releases. So when we talk to customers, we see this is one of the biggest like pain point for platform engineers. As you know, Kubernetes, they have fast release cycles. So now we provide 24 months for support for all the VKR, meaning customer they don't have the like urgent pressure to upgrade right away. And it's also stabilized the environment, free up the team to focus on delivering value instead of constantly planning upgrades, because we provide 24 months support for the VKR versions. And also built-in tools are important. We provide the built-in GitHub integration with popular tools like Argo CD, Helm. So this makes it easy for teams to push code, automatically deploy apps, and then maintain consistency across the clusters. The fourth one, we have multi-cluster life management policy and a backup at a scale. Like I mentioned earlier, this is a VKS cluster management. We deliver control, efficiency, and security to platform team, so who are looking to simplify Kubernetes operations. The last one is single API across all our building block services. Because we want to ensure we have a unified management experience for our personas, for VMs, Kubernetes clusters, and other resources, all through a single consistent API, which simplifies operations and reduce the need for separate platforms to manage different resources. And the benefit is the developers and the platform engineers, they get a unified interface, and they can accelerate integration, automation, and innovation. So the last key persona, decision makers. So what matters to them? The first is they want to modern their applications at a lower cost, because with the VCF containers and the VMs, we are running on a consolidated infrastructure, which eliminates the silos and reducing license cost. At the same time, we also want to help with, simplify the infrastructure for them. The second part is the fast time to value. So we enable faster application delivery, so organizations, they can move from ideas to production more quickly. So this means like the transformation projects deliver value sooner and start producing ROI earlier, which is a key fact for decision makers. Security and compliance, like Lee mentioned earlier, this is really important for all organizations when they consider or they already adopt modern applications. So we have a better protection with the 6 layers of isolation, like I mentioned earlier, and our data in VCF is also encrypted end-to-end, and both at a risk and in transit. The fourth part is our open source leadership. So Broadcom is the top 5 contributors in the past 5 years. We actively contribute, support, and participate in CNCF projects. So the projects we spent from VMware originated projects, such as the example like Contour, Valera, Harbor, and we also support other projects like cluster APIs, which simplifies Kubernetes cluster management. We also participate in the advocacy and the thought leadership. We support CNCF and the Linux Foundation, engage in special interest groups, six to drive innovations, and participate in KubeCon again in Atlanta. Broadcom will have a big presence there. The last part is skill gaps. So we all know the major barrier to modernization sometimes is a skill gaps, because we want to all the organizations they want to avoid retraining staffs or hiring more experts for Kubernetes. So BCF will ensure that existing teams they can leverage familiar skills while managing Kubernetes. So this closes skill gap, reduce risk, and accelerate innovation by making team more productive from day one. Okay, so now let's talk about our customers' toughest challenges when they're adopting or consider adopting modern apps. The first is the modern app modernization. So a lot of organizations, they want to accelerate the delivery of modern apps, but they also need to do it in a secure and a consistent way. With our built-in cloud services and a centralized policy, we make sure they can manage access, networking, and security while also driving faster app delivery. The second part is the regulated workloads. So, like Elise mentioned earlier, again, the security compliance is very important, and we care that for customers. We provide isolated and fixed compliant Kubernetes environment for our customers. So they can deploy clusters that meet the most strict government requirements without complexity. We also have the end-to-end data sovereignty for ensuring the workloads and the data stay within the same location and the organization boundary. The third one is running AI and ML workloads. This is require like special services and governance. So with our private AI services built into the VCF now, customers they can build and run these workloads without you have to go to another platform or maintain a fragmented stack. The fourth one is we see a strong need for the modern private cloud deployment, meaning like organizations, they want Kubernetes operations to look the same and consistent across environments like on-prem, public cloud, edge. So with VKS, we get that consistency. So app can run anywhere without silos or then having the needs for refactoring. The last use case we've seen is dev and test environment. It can be a constant challenge for our developers because they need a isolated cluster so they can quickly spin up and tear down. So our platform makes sure that process is simple and reducing the cost, accelerating delivery cycle by enabling a parallel testing and fast feedback loops. Now we are towards the end of my section. Why I'm having this slide is so important because a lot of times after presentation, we want a quick ramp up, a summary of, hey, tell me about the VCF in one sentence. Now here is the slide for you. We all know VCF is the single platform for VMs and containers. What is VKS? It's a built-in Kubernetes runtime in VCF that orchestrate all our containerized workloads. And also, if you remember, we mentioned VCF, we include a comprehensive set of the Cloud services in VKS, we call the core packages and stem packages to build modern containerized workloads for our customers. Last but not least, we have the VKS cluster management, which delivers control, efficiency, and security to our platform teams. Now I'm gonna hand over to my coworker, Natalie.
All right. So thanks, Audrey, for walking us through how VCF delivers a modern, secure, and flexible platform for both VMs and containers, as well as giving that run through of the different personas that we support. And thanks to Lee for setting me up for this section, because there is a key ingredient that we haven't fully unpacked yet, which Lee kind of alluded to in the beginning, and that's open source. So open source isn't just a checkbox in our architecture. It is the foundation that we build on and the ecosystem that we are helping to shape. So whether it's Kubernetes itself, tools like Harbor, etcd, or CAPI, the reality is that open source is driving the innovation that our customers depend on, especially as they modernize inside the private cloud. So in this section, in my section, I'm going to walk you through how we think about open source, not just what we're using, but what we're contributing to, how we're supporting it, and how we're trying to make it enterprise ready. So I want to talk about why open source is so foundational to how we build modern private cloud platforms today. We understand that platform teams are under pressure to deliver the same outcomes that developers expect from public cloud. So they need fast provisioning, they need secure pipelines, they need GitOps, observability, and of course, increasingly AI ML. But they need to be able to do this within the constraints of internal infrastructure, policy, and compliance. And the reality is that open source powers almost every single one of those building blocks. And according to CNCF, the Cloud Native Computing Foundation, over 90% of organizations rely on open source software somewhere in their native stack. The Venn diagram here captures those key ingredients that can make open source enterprise ready. So we have innovation velocity. So upstream projects like Prometheus, Argo, and Harbor, they move fast and they evolve quickly. There's also enterprise flexibility. So these tools integrate cleanly across clouds, clusters, and CI/CD pipelines, and operational trust. And that's where VMware is stepping in. We want to make sure that these tools are secure, they're upgradable, they're lifecycle managed and supported. And so when all those three elements intersect, open source moves from being a promising project to being a reliable platform foundation. And that's what we're committed to enabling in VCF. Next. We also understand that adopting open source at scale isn't always easy, especially in private cloud environments where reliability, lifecycle, governance, it really matters just as much as feature sets do. And that is why we are more than just consumers. VMware is engaged with open source, and it goes far beyond just bundling it into the product. We are actively contributing, we're originating, and we're partnering in ways that help open source succeed in enterprise environments. So I wanted to share a few examples here. We have Harbor, which is our CNCF graduated project. It started at VMware, and it's now a widely adopted secure container registry across industries. And it's become foundational for trusted image distribution and context signing in cloud native pipelines. We are also active contributors and maintainers to CAPI or Cluster API, which simplifies that lifecycle management of Kubernetes clusters. It's a core need, of course, for platform teams managing multi-cluster environments. And our work here directly supports our own capabilities in VCF, while also strengthening that upstream ecosystem. And we also contribute and are maintainers to etcd. So that is the critical store behind Kubernetes. And it's not just about participation. It's also about ensuring that performance, reliability, and safe operations at scale, which is going to benefit every platform team running Kubernetes. But beyond the code commits and beyond the code, we also engage in CNCF working groups, SIGs, and governance conversations. And we're really proud to have a number of our VMware engineers as maintainers and KubeCon speakers that are really kind of helping to shape that future of Kubernetes in collaboration in an open and transparent way. And because we know that no platform exists in isolation, we also partner with the ecosystem, like Canonical, who we have built a really unique product with. We've created this enterprise hardened integration. We are delivering with Canonical VCF plus Ubuntu with full stack enterprise support. And we are giving customers secure, fully supported environments from OS to containers. And this includes chiseled containers to reduce attack surface, fast patch pipelines, and precompiled GPU drivers to simplify AI and ML workloads, even in air-gapped environments. So this is a really unique offering. No other private cloud vendor delivers this level of integration and OSS alignment for enterprise and AI native infrastructure. And this is the type of partnership that we at VMware want to continue to strive for and foster. So when we talk about open source and it being foundational, we really mean it. We back that with our upstream work, and we prove that the outcomes are not just for us, but for the entire CNCF and Kubernetes community. Next. All right, so we also understand that platform teams don't just need tools, they need outcomes. So we want to take a moment to show what good looks like when open source services are delivered through VKS and VCF. So one of the areas is GitOps consistency. So we have an Argo CD operator style service that teams can automate deployments confidently across clusters. We have Harbor, which delivers a secure registry. And it's not just open source, right? It's signed, it's policy driven, it's integrated into the platform. And while Harbor is VMware's integrated secure registry, we understand that some teams have other existing registries they rely on. And because VKS, our Kubernetes service here, is CNCF certified Kubernetes, it adheres to upstream compatibility standards, so you aren't locked in. You can bring any registry of choice, whether it's Harbor, Docker Hub, Artifactory, whatever. It's going to work within the platform. We also have Istio as a standard package, so that gives you service mesh capabilities. This is going to include things like intelligent traffic routing and built-in MTLS for secure service-to-service communication. This helps platform engineers secure and route workloads with confidence. And then for backup and DR, Valero is embedded in the platform, so it gives you recovery that you can trust. It's backed by secure upgrade paths and tested compatibility. And of course, DNS and runtime are included by default with core DNS and containerd. It's built into every deployment. And both of these are critical under the hood components for stability and performance. And we aren't just shipping them, we are also contributing upstream to containerd and helping sustain that very core of the Kubernetes experience. And of course, there's compliance because these are upstream aligned packages. Customers retain OSS transparency. And this also means that, like I said, we're taking open source seriously. We're not just using it. And these are the outcomes that platform teams should expect from a private cloud. Next. Okay, so we understand that modern platform teams, they are no longer just managing infrastructure. They're curating experiences, they're enabling innovation, they're enforcing policy in increasingly complex environments. And to do that well, they need more than just Kubernetes. They need a trusted platform. And so that's why our approach is centered on giving teams the best of open source with real lifecycle support, security, and upstream transparency. So like I said, we're not just integrating with open source, we're contributing to it, we are operationalizing it, we're ensuring that it works within the enterprise environments where it matters most. And so as you think about where your platform strategy is headed, especially in this space of rising regulatory pressure, multi-cloud complexity, and internal developer demand, remember, you don't need to sacrifice control to get cloud outcomes. You don't need to choose between innovation and stability. And open source doesn't mean on your own. It means choice, it means community, and when it's done right, it means confidence. And that's what we're trying to build with VCF and VKS. We're trying to build this platform that's going to be shaped by community, it's going to build for the enterprise, and be ready for whatever's happening next. We believe that open source thrives when it's supported by real world use and thoughtful contribution. And that's how we want to approach this future of private cloud. I also want to add that if you're heading to KubeCon North America, we would love to connect with you. Come visit the VMware booth. It's number 1010. Come meet our engineers, come meet our product managers, see our demos, see our Kubernetes in action, and learn how we're contributing to different open source projects. So that is it for me. I just want to say thanks for spending time with us today and your interest in how private cloud, Kubernetes, and open source are evolving together. So I think we can probably just take this moment to answer some questions. I did my best to try to answer them while talks are going on. All right, let's see. So someone asked, is it possible to share the slides? It sounds like we're not sharing the slides. We are sharing the recording after the session. Let me see. Okay, so Manisha asked if we have currently VCF 5.2.2 and we need to run Gen AI using private AI, is it good to deploy on a fresh VSF 9.0? The answer is yes, especially because I don't remember, I know I answered this question. I don't know if everyone else saw the answer, but Private AI Foundation is now a part of our VCF 9.0 SKU. Is there VCF 9.0.1 document for getting Prometheus set up and going? I think there's general documentation around how to set up standard packages within VKS. I think the expectation, though, is that you would go to the Prometheus site, but let me find out, Joshua. What are the challenges running VCF 9.0 with private AI and VKS on existing VCF 5.2.2 platform and having management console for VCF 5.2.2? So unfortunately, Manisha, I actually don't know the full answer to this question. But
we also have some resources for upgrading path from 5.2.2 to 9.0. I think possibly you can find on the VMware Cloud Foundation website that we have resources for you.
And then I think, let me see. Do the open source project apps such as Istio, Valero, and Prometheus also have support? So the answer to that question is if it is part of our standard packaging that we support within our VKS, the answer is yes, we do support it.
There's one more for the air gap environment for VCF.
All right, so the other question is, can you share air-gapped environment for VCF 9.0 with private AI, VKS, and private cloud reference architecture? I don't have that on hand, unfortunately. If you can, Manish, if you can maybe reach out to your account manager and ask them, and we're happy to share this.
I think we answered all the questions.
Okay.
Alrighty, I think we're towards the end of our presentation. Thank you everyone again for joining us for this 1 hour presentation, and hopefully you learned something new from here. And anything else to share, Lee and Natalie?
I want to thank everybody for inviting me. Happy to be part of the discussion.
All right, thanks everyone. If anyone thinks of any other questions, feel free to reach out to me on LinkedIn, I guess. I don't know how else you guys would get a hold of me.
All right, thank you everyone.
All right, thanks guys.